This we cannot do, so hold on to these as I mentioned. This will be a review for test 3. This we cannot do just yet. Let's see what we have here. Yes, this we can. And this is the end of this test. And we'll look at the orange one in a minute. Okay, so here we are asked to do what? What is this problem asking us to do?
In the range.
It's asking us to graph what type of function. It is a rational function. So we have to go through pretty much the same steps, but a little bit more. Why more? Because this function has, in addition, things that the polynomial functions don't have. Can anyone give us an example or examples of what features a rational function has that a polynomial will never have?
X in the denominator.
Correct. That's one. There is no x in the denominator in a
Points for
polynomial.
which the function is undefined.
Correct, which means asymptotes. Very good. Vertical ones. What else?
Horizontal asymptotes.
Correct. What else?
Possible holes.
Say it again.
Possible holes.
Holes in the graph.
Oh, yes, of course. Thank you. Yes, absolutely. Yes, which polynomials will never have. Correct. It could possibly have a slant asymptote. All sorts of things that don't happen with polynomials. Very good. Okay, so we'll get the chart going. Fill it in and discuss step by step. Where is the starting point?
Negative infinity.
2. So what would be the starting point then?
Negative 2.
So what would be the starting point? What am I looking for first? Definitely, I'm looking for
Boundaries.
domain. Correct. Good. So look at the function and say, ah,
All real numbers except 2 and negative 2.
2 and negative 3.
Negative 3.
2 and negative 2. I'm sorry. Very good.
So I
Indeed.
said I must be reading the
Yeah, no,
graph
for
wrong.
some reason I looked at it and I thought it was x plus 3.
I've done worse. So,
Thank you very much. My mistake. Good. So we know that the function is undefined and negative 2 and 2. Perfect. Then what will be my next step?
behavior from integral behavior. You know, like from negative infinity to negative 2, negative 2 to infinity.
Nope,
Isn't the asymptotes good?
not yet. Let's look at the function carefully.
You can simplify it, right?
Exactly. I have to.
1 over x plus 2.
Very good. Absolutely. 1 over x plus 2. Now I have to identify what happens at negative 2 and what happens at 2.
2 becomes a whole.
Yes. How do I know that x equals 2 is indeed a whole? And how do I know that x equals negative 2 will be very good? Not as an asymptote, but the vertical one.
Right.
Correct. How do I know that? Can anyone explain how do I know, how did I know that x equals 2 is a whole?
Because the
Factor,
factor just went away.
exactly. And the remaining factor in the
It's
denominator,
still there.
exactly. And that's why this will become
A vertical asymptote.
a vertical asymptote. Do you need me to repeat what Tom just said? Is it clear? Should I repeat it? If the factor goes away, it's a whole. If the factor doesn't go away, it's a vertical asymptote. Good, perfect. So once you say a vertical asymptote, then what do we have left and right?
Negative 2.1 and negative 1.9.
But what do I expect to have for sure before the sign is determined? It has to be infinities. Once we say vertical asymptote, left and right must be infinite. Good. So now with the negative 2.1, let's plug in negative 2.1 and just give me the sign.
Positive.
Negative 2.1 plus 2 is negative. That's okay. So let's plug in now negative 1.9.
Now this is
Absolutely agreed. Now let's plug in 2. And give me the number here and the number here. It's a whole, so it has to be a number. It cannot be infinity. So, very good. 1/4 indeed. 1/4. So can anyone give us the open point or the hole in the graph? The coordinates of that open point. 2, 1/4. Awesome. Good. So we have behavior near the asymptotes, intercepts, max min, and so on and so forth. Okay, good. So we know the vertical asymptote. Is there a horizontal asymptote? What type is, I should have asked from the beginning, what is the type of this function? What type is it? Is it type 1, is it type 2, or type 3? Type 2, which means the horizontal asymptote is always 0. So it's type 2, 0, the end behavior and the horizontal asymptote. Very good. Next.
symmetry.
Okay, so we have all the asymptotes. We have behavior near the asymptotes. We have the end behavior. Okay, can a function with a vertical asymptote at -2 and a hole in the graph on the other side of, no. So I'm going to say f of negative x does not equal f of x, and it does not equal negative f of x. Therefore, not symmetric. Good. Symmetry. Intercepts. I have to have 0 in the chart, no matter what. So please plug in 0 and tell me what you get.
Zero. Wait. 1/2.
Very good. So can this function be 0?
Yes.
A fraction is 0 only when?
Only when. Where do I put it?
The numerator is 0. Okay, let's make the numerator 0. How much is x?
0.
There is no x in the numerator, right?
0/2.
But there is no x in the numerator. You have to set the function equal to 0, right?
Oh, I see.
So for the x-intercepts, we set y equal to 0, which means 1 over x plus 2 equals 0, which means 1 equals 0. But can 1 be 0?
No.
No. So there are no x-intercepts. Good. So we finish with that. Max min we'll see when we discuss the graph. And this is pretty much it. And we can find the range of the function in a minute after we graph it. Okay. So let's try and make sense of this information. See if it makes any sense. From approaching 0, comes down to -infinity on the left-hand side of the vertical asymptote. In the middle, between the two asymptotes. I'm sorry, forgive me, this is not an asymptote, it's a hole, sorry. So on the other side, from positive infinity, crossing the y-axis at 0, 1/2, going through a point, an open point, 2, 1/4, and approaching 0. Continue to decrease towards 0. One more time. So from 0 down to -infinity. On the right-hand side of the vertical asymptote, from positive infinity, crossing the y-axis at 0, 1/2, going through the point 2, 1/4, and approaching 0 eventually. When we graph a function with asymptotes, what do we have to graph first? The asymptotes. So this is an overkill. There is no need to write y equals 0 because that's the x-axis. And x equals -2 is this point, this vertical asymptote, x equals -2. I do have to have 0, 1/2, so I'm going to say 0, 1/2 is this. And 2, 1/4 is this point. Kind of squeezed in there. So on the left-hand side from 0 down to -infinity. On the right-hand side from positive infinity, crossing the x-axis, going through this open point and approaching 0. You can check this with a graphing calculator if you choose to. Obviously, there are no max min. So in y equals, make sure you put the correct function in. If you put the simplified form, you will not get the open point. So you have to put in the original function. So the numerator in parentheses, which is x minus 2, close the parenthesis, and you must put parentheses around the denominator. You keep each factor in parentheses, but also another set of parentheses outside of the denominator. So the left parenthesis again, x plus 2, close, parenthesis x minus 2, close, and close again. There is no point in writing y equals 0. You can if you want to, as the horizontal asymptote. There is no need because that's the x-axis. So the viewing window, I'm going to choose the same thing that I had before. Well, let's see what happens. Okay, as expected, the graph is not, or the graphing calculator, I would say, is lying to us. Not on this side, but it's lying on this side because at 2, there is an open point here. So I'm going to zoom in so I can show that point. Or you can just go to second and table and plug in 2. And table. So if you want to plug in 2, and I press enter, what will I get?
An error.
Of course. I have to, because there is an open point there. Or you can go to the viewing window, and I'm going to change it to 0 to 3. And scale of 1 is fine. And let's say -1 to +1, because I know the point is at 2, 1/4. And just press graph. And it should show. It doesn't. It's right here. So between 1 and 3, 2, I'm going to reduce this. I'm going to say the viewing window. We don't have to do this. But I'm just showing that the graphing calculator is not perfect. See? I still don't see it. Okay, so I'm going to reduce this too. Because I know it's 2, 1/4.25. So I'm going to say y maximum is 0.5. And I'm going to say this is 1. Well, let's see. Will it show it now? Yes, finally. So that's the open point at 2, 1/4.
So there's no maximum value.
No, because the function is constantly decreasing. Very good point.
I mean, one more time?
The function is constantly decreasing. Follow my hand. For max or min, the function has to turn. Has to increase, turn, decrease, turn, increase. The function is constantly decreasing.
I got you. Okay.
There is no turn, there is no increase. So a turn requires increase, then decrease, or decrease, and then increase. But since this function is always decreasing, very good point. This function is always decreasing, there is no turn, no max min. Very good, awesome. Okay, we're done with this. Let's take a look at the orange one and see what we have in there. I think we had looked at a problem similar to this. We can come back later if you want, but I would like to move on to the factor theorem and the remainder theorem. Synthetic division, long division. So this problem is from synthetic division, long division, factor theorem, and remainder theorem. So it says use the method of your choice to divide p of x by x minus 2. And state if p of x is divisible by x minus 2. And I want to add a question here after we do that. So which method would you like to apply? Does the long division, is the long division a good method? Is it applicable? Is the synthetic division good here? Is it applicable? What do you think?
I don't think synthetic is applicable.
It is.
It is, because I'm dividing by x minus a, which in this case, a is 2.
Oh, for number 2, yeah. Oh,
Yes, for number 2.
my bad.
Yes, no problem.
Yeah.
So we have p of x, which is x to the 4th. Maybe if we write it like this first, will be easier for us to identify. So it doesn't matter, for this problem, it doesn't matter which method you apply in this case, because I can apply the long division and I can also apply the synthetic division. So which one would you like to apply to find whether x minus 2 is a factor, in other words, of p of x? Want to apply long division, synthetic division, and I'm going to ask you, is there something else that I could do to identify whether x minus 2 is a factor of the polynomial at the top? Is there anything else I could do? Do we remember?
I should, but I
Okay, so we'll discuss it step by step. First of all, we want to divide using synthetic division or long division, and then I'll refresh your memory on that, on those two theorems.
synthetic.
Are we okay with synthetic? Yes? Okay, so let's do synthetic then. So let me put it here. So x to the 4th minus 4x squared plus 2x plus 5 divided by x minus 2. Good. So what goes in the box? Since we decided to use synthetic division. What goes in the box?
2.
2 indeed. Good. And the coefficients now.
1. -4. 0. Up. Down. Yeah. 0. Now. -4. 2. 5.
Very good. Do we remember this? Is this okay? Perfect. And then how do I start the algorithm?
Scenario.
Yes, it's called, like a scheme if you want. Yeah, step by step algorithm.
Bring one down.
Yes, awesome. Bring one down. Good.
Multiply.
Yes, 2 times 1 is 2. And then,
Add.
good, 2. 2 times 2,
4.
good. Add, 2 times 0, good. Add, 2 times 2. And what do I box in?
9.
Very good. So, the degree of the top, please.
4.
4. The degree of the bottom, please.
1.
When I divide degree 4 by degree 1, what degree should the quotient have for sure? Good. So please give me the quotient starting with x cubed.
X cubed.
Thank you.
Plus 2x. Plus 2.
Squared.
Very good.
Plus 2x.
Since this is 0, 0 times x. And now plus 2, and then plus
9 over x minus 2.
9 over x minus 2. Any questions here? Is this okay? Please ask. Don't be shy. So here's my question. Can I conclude that x minus 2 is a factor of the numerator?
Mm-hmm. Wait.
I can or I cannot.
Due to there being a remainder, it's
If
not
there is,
factor.
if the remainder is not 0, x minus 2 cannot be a factor of the top, right? So I will say x minus 2 is not a factor of p of x, since the remainder does not equal 0. The remainder is 9. As long as the remainder is not 0, x minus 2 is not a factor of the top.
What's the shortcut for that?
What is the shortcut for that? How do I determine the remainder without going through the process of finding the quotient. So if you ask me just the question, I don't care for your quotient. Just tell me whether x minus 2 is a factor of the polynomial from the top. What will I do quickly without finding the quotient? Anyone remembers? Anyone remembers how we determined that? Okay. Only for the division p of x divided by x minus a. So for example, if I have this, don't correct anything, I'm going to erase this. If I have this, I can no longer discuss what I'm going to discuss. But since the denominator is x minus a, and I'm going to delete that once I find my whiteout. Here it is. Because the division has a divisor that works with a synthetic division, only because of that, so I'm dividing this by x minus a, the remainder, only the remainder of this division is p of a by the remainder theorem. So I'm going to put it in parentheses. Yes, by the remainder theorem. So here's p of x, polynomial p of x, x to the fourth minus 4x squared plus 2x plus 5. And I would like to check my work and find the remainder using the remainder theorem. If the remainder is 0, then I would say x minus 2 is a factor. If the remainder is not 0, like we discovered, we got the remainder to be 9. When we determined it was 9, then I will say x minus 2 is not a factor. But how do I determine p of a? So I can check my remainder. P of
A. Can't be A, but that you just said it was
P of,
-2.
if this is minus 2, it complies with minus a.
Oh, 2.
2, indeed. It's the same thing that we put in the synthetic division. Good. So then we have 2 to the fourth minus 4 times 2 squared plus 2 times 2 and plus 5. How much is 2 to the fourth?
16.
But how much is 4 times 4?
16.
So 16 minus 16. How much is 2 times 2?
4.
How much is 4 plus 5?
9.
What did we expect to get?
Remainder of 9.
A remainder of 9. So then we conclude again.
It's
We
not a
just check.
factor.
It's not a factor. X minus 2 is not a factor of the polynomial in the numerator. Any questions for me, please? Okay, let's move on. In problem 3, we're given 4 functions. What type of functions are these? Yes, they are rational functions. I'm not going to have enough room there, so I'm going to copy them here. So f1, 2x minus 1 over x squared minus x minus 2. f2, x to the third plus 27 divided by x squared plus 4. f3, x to the third minus 9x over x plus 2. And f4, x squared plus x minus 6 over x minus 2. So one more time, what type of functions are these?
Rational.
Yes, because they have
X in the
a fraction
denominator.
and the denominator has x in it. Yes, good. What type is the first one?
Type 2.
Correct. Type 2. What can I write right away, right here, right now about type 2? I know something specific.
Horizontal asymptote is 0.
Very good. That's pretty much all I can say right now. I haven't factored the denominator. I don't know the domain, but right now I can say it's type 2. Why? Because the degree in the denominator is
Greater than in the numerator.
greater than the degree of the numerator. And these two go together. Awesome. What about number 2? What type is it? Is number 2?
3.
Yes. What do I know about type 3 right away without even graphing it?
No horizontal asymptote.
Awesome. But very good. That's what I know immediately about type 3. It has no horizontal asymptote, but it will have a slant asymptote. Awesome. What about F3? What can you say about F3? What type is F3? Unknown. Which means, does it have a horizontal asymptote?
No.
No. Does it have a slant asymptote?
No.
No. Totally unknown to us. Very good. Okay, what about F4?
3.
Yes, type 3 again. And what can we say immediately about type 3?
No horizontal has a slant.
Yes,
Gesture.
that's okay. I'll pick it up. No horizontal, but slant. Now you understand this is a preliminary discussion. So this preliminary discussion does not take into account any holes in the graph or vertical asymptotes, nothing. We just identified what each and every one of them represents, pretty much. Okay. Part A. Which of these functions has vertical asymptotes? So what do we have to do now to F1 in order to find if it has vertical asymptotes or not? I have to? Right, or factor it. Correct, correct. So then I have 2x minus 1 over? X minus 2 times x plus 1. Does this function have vertical asymptotes? It does? You're correct. This factor does not go away. This factor does not go away with anything from the top. So x equals and x equals are both vertical asymptotes, for sure. And what are they?
You just said vertical asymptote.
Yes, but I have to write x equals.
Oh, x equals -1 and 2.
Very good. Do we agree with this? When x minus 2 equals 0, then I have x equals 2. When x plus 1 equals 0, then I have x equals -1. Agreed? Yes? Good. So I'm looking now at F2 for the same question. I have x cubed plus 27 over x squared plus 4. Does this function have vertical asymptotes? It does?
No.
Perfect. Why this function does not have vertical asymptotes? Correct. Because x squared plus 4 is always a positive number. No vertical asymptotes. Meaning x squared plus 4 is never 0. X squared is a positive number no matter what you plug in, but then you have to add 4 to it. Even if this is 0, which is the smallest, plus 4 will be a positive number. Imagine the graph of x squared plus 4. X squared, and where is the transformation? What do I do with the graph of x squared to get x squared plus 4?
Find the square root.
No, which transformation?
Oh,
Say it again.
What was the question?
I just want to graph this in our minds, with our mind's eye. Correct. But what transformation is to x squared, to get x squared plus 4?
Move on for a unit.
Exactly. So that's why it's always positive. Never 0. So that's why if the denominator is never 0, there are no vertical asymptotes.
Slant asymptote can't have like a negative slope then?
We're only talking here, the question, you're right. So which of these functions have vertical asymptotes? But it doesn't have any connection to the slant.
Okay.
So a function, a rational function, can have a slant asymptote and vertical, can have a slant asymptote but no vertical.
Okay.
So this is the case here because x squared plus 4 is always positive. Was that the question? Okay, perfect. Okay, F3. Does F3 x cubed minus 9x over x plus 2, does this one have a vertical asymptote? So when we talk about vertical asymptotes, we are really asking ourselves, can the denominator be 0 or does it go away with the factor from the top?
I think it can be 0.
Correct, because the numerator is x times x squared minus 9 over x plus 2, and you factor x squared minus 9 how? Very good. That's our agreement. Very good.
It'll go away, so.
Exactly. Nothing will go away, so what will I say about F3? Does F3 have a vertical asymptote?
It has 1,
Yes, x equals
negative 2.
-2 is a vertical asymptote. Okay, last one, F4. X squared plus x minus 6 over x minus 2. We're asked to identify whether this one has a vertical asymptote. What do you think I have to do first?
Factor the top.
Awesome. Because I can make a decision before I make sure what? That x minus 2 from the denominator?
So you can see if it can be taken away or not.
Exactly. If it goes away with a factor from the top. Very good. Awesome. Everything falls. You cannot fall further than the floor. It's not a big deal. Okay, the numerator.
X parentheses.
I cannot factor out x from the 3 terms I have.
Did I get that right?
So how do we factor the top? Say it again. Yes, it is a quadratic, so I have to. You can, but these numbers are pretty. Yeah. So the product is -6 and the sum is 1. Correct. So x plus 3, x minus 2. That's okay. That's okay. So then what do we observe? I still have to, I cannot touch it before I write a restriction. What is the restriction?
Cannot equal 2.
Exactly. And now what do I do?
Cancel those 2 out.
But not before I write this.
Yeah.
So the simplified form is?
X plus 3 over 1.
So then what will I say about x equals 2? Will it be a vertical asymptote or hole in the graph? Indeed. So let's come back because we have to write an answer. Does the first function have a vertical asymptote or has vertical asymptote? Does it have vertical asymptotes?
F4 does not.
F1 does. F2 does not. What about F3? Yes. What about F4?
Nope.
No. So the two functions from the list of functions that have vertical asymptotes is number 1 and it's number 3. Good. Next question. So we identified and we determined all vertical asymptotes. Which of these functions have a horizontal asymptote? This we already identified from the very beginning. When we listed them the first time, we identified which one has a horizontal asymptote. Which one has a horizontal asymptote?
Fun.
So the first one has a horizontal asymptote. The second one does not. The third one definitely nothing other than the vertical. And the fourth one does not have a horizontal asymptote because it's type 3 and it has a slant. It cannot have horizontal and slant. Okay, so it's only the first one. So only F1. Can anyone tell us or give us the horizontal asymptote? We already wrote it. Y equals 0. Good. Which of these functions does not have a vertical asymptote? So there is basically, this is an overlap of a question. So I will say again, F2 and F4 do not have vertical asymptotes, and we explained why already. So F2 and F4 do not. Which of these functions have a hole in the graph? What will I say? Will be the answer. F4. F4 has a hole in the graph. Okay. Which of these functions have slant asymptotes? Let's go back to the first step here. Does this one have a slant asymptote? Yes. Does this one have a slant asymptote?
Yes, ma'am.
However, now, because I know it's there is a hole in the graph, and it reduces basically to what type of function is this? So linear. I will say the function is the slant asymptote. The function is its own slant asymptote. As long as I didn't divide, I have to divide. If I don't divide top by bottom, there is no slant asymptote. The function itself is the slant. So the only one that I have to divide is this one to find the slant asymptote. So x to the third, space, 27, and x squared plus 4. So how do I start? X squared times what is x cubed?
X.
Very good. I go back and distribute and write underneath like terms, and also switch the symbol.
Minus x cubed.
Very good.
Minus 4x.
But I cannot write it here, but I have to write it here minus 4x. So now negative 4x and plus 27. Can I continue? X squared times what is negative 4x? No, not possible, because this is degree 2 and this is degree 1. So what is the slant asymptote for this function? For function 2? Y equals?
Negative 4x plus 27.
This is the remainder.
Oh.
The remainder has nothing to do with the slant asymptote, only the quotient. So y equals x is the slant asymptote. Okay, final question here. Graph only one of these 4 functions and show the relevant or applicable information. So let's go back.
It's a lot of steps for just 16 points.
Good. So let's look at the first one. So this one is type 2. It will have a horizontal asymptote. That's potential, right? This one, I don't want to worry about. The slant asymptote, it has too much work. This one I cannot. So this is a waste of time. This is a waste of time. This is basically what? What function is the fourth one? What did we say? It reduces to or simplifies to what?
X plus 3.
Right. So the 2 potential ones that I would think of graphing is either this one, which is type 2 with a horizontal asymptote at 0, or this one, which is basically what?
Just a linear function.
A linear function with a hole in it.
Mhm.
So which of these two functions would you consider? Would you consider f1 or would you consider f4?
Easily F4.
Of course, by far. It's the easiest thing to do. So I will graph the linear function x plus 3 with a hole in it. So it's f4 equals x plus 3 with x not equal to. So what will be the open point or the hole? 2, comma, have to plug it in as we did before, 5. So, now no asymptotes, this is a linear function, 2 comma 5, 1, 2, 1, 2, 3, 4, 5. And then I will determine 2 points for y equals x plus 3. When x is 0, how much is y?
2. 3.
Good. And when y is 0, x is?
-3.
Very good. This is it. This is the graph of f4. Obviously the easiest of the two.